for our section 6.6. We're going to look at the converse of the Pythagorean theorem. So we know that the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are legs of a right triangle and c is the hypotenuse. What we need to do in this section, and this is on your skills practice for 6.6, the lengths of three sides of a triangle are given. Determine whether each triangle is a right triangle. So either it's a right triangle or it isn't. If it's not a right triangle, what kind of triangle could it be? Well, if it's not a right triangle, it could be acute or it could be obtuse. So we're going to look at these three side lengths, and we're going to show you how to determine if it's a right triangle, an acute triangle, or an obtuse triangle. And it's just using the converse of the Pythagorean theorem. So if these three numbers work in the Pythagorean theorem, then it's a right triangle. That's how that goes. So 3 squared plus 4 squared, does it equal 5 squared? Well, we've gone over that problem quite a bit. It definitely does. And if you don't remember, you can go back and look at your triples. If you have these three lengths, it's a right triangle. So there's really not a whole lot of work to be shown here. This is definitely a right triangle because it's a triple. Now this next one, 2, 2, 4, it's not a triple. So what you're asking yourself is, 2 squared plus 2 squared, does that equal, I'm putting a little question mark there, does it equal 4 squared? Well, you can do this in your head. 2 squared is 4, 2 squared is 4, 4 plus 4 is 8. 4 squared is 16. Does 8 equal 16? It definitely does not. 16 is bigger than 8. 8 is less than 16. When this happens and your right side, your hypotenuse squared, is bigger than your legs squared and added, this is an obtuse triangle. So for number 20, the triangle is obtuse. Number 22, we have 5, 10, and 15. That's not a triple that I recognize. That doesn't mean it can't be a multiple of a triple. Does 5 squared plus 10 squared equal 15 squared? Okay, now these numbers are getting a little bit bigger, so it's probably not a bad idea to use your calculator. We're going to type in 5 squared plus 10 squared. We're also going to type in 15 squared, and we're going to see if they equal each other. Okay, they don't equal each other. 125 is less than 225. So remember, when this side's bigger, it's an obtuse triangle. We didn't really talk about it yet, but what would make it acute? Well, if this side was bigger than that side, you would say it's acute. Okay, let's try these ones over here. Number 19, 1, 1, and 2. Well, didn't really want to go over an example like this here, but I guess we're going to have to. You don't know this yet, but your two smallest sides on a potential triangle must add together and be bigger than the biggest side. 1 plus 1 equals 2. 1 plus 1 is not bigger than 2. So this doesn't even make a triangle. So we'll go over this more in detail at some point. This was a really poor example that they threw in there, but since they did, I guess we're going to talk about it. Number 21, 8, 15, 17. That sounds very familiar to me. 8, 15, 17 on my triples list. That means that's a right triangle. Now, if you didn't catch the whole triples thing, 8 squared plus 15 squared equals 289. What's 17 squared? See how it's the same 289? So if you didn't catch the triples shortcut, you could still do this. And how long did that take? About 6 seconds? The numbers are equal. That's why it's a right triangle. Number 23, 14, 48, 50. I know what's happening here. If I would divide all of these by 2, I would get 7, 24, 25. Now, that's going to take you some time to develop that vision, but I know that 7, 24, 25 is a triple. So I know this is a right triangle. And again, if you did not know that that was a right triangle, or you did not see the triple shortcut, then you could do 14 squared plus 48 squared. That gives you 2,500. 50 squared is also 2,500. That's why it's a right triangle. Okay, so that was your skills practice for 6-6. Now, we're also looking at the practice for 6-6. We're doing the same thing. Would these three lengths make a triangle? What the heck? This is the same freaking example. 7, 24, 25. That's a triple. So that's a right triangle. I'm looking for an acute triangle here to show you. 15, 36, 39. Yeah, that looks really familiar to me also. If I would divide all of these by 3, I would get 5, 12, 13. Look at your triples list. 5, 12, 13. Again, that's a right triangle. Number 14, 50, 75, 85. That doesn't really sound familiar to me. I'm going to check what 50 squared plus 75 squared is, and I want to see if that equals 85 squared. 50 squared plus 75 squared gives you a big number. What's 85 squared? That's a big number too, but it's not quite as big. So that 8125 is bigger than 7225. What does that mean about the triangle? If this left side is bigger, it's acute. And that's the example I've been looking for here. Let's do one more, since there's only one more. 45, 60, 80. 45 squared plus 60 squared. That gives you something. What about 80 squared? Let's compare those. 45 squared plus 60 squared. That gives you 5625. I'm going to compare that with 80 squared. And that gives me 6,400. 6,400 is bigger. That's the right side. So that makes this triangle obtuse. That's the converse of the Pythagorean theorem. If you have three numbers, put it in the Pythagorean theorem and see if it makes a right triangle. If it doesn't, then it's either acute or obtuse.